Hello, my name is Marybeth Umstadt, and this is my project for the course project. This is my poster, and this is my presentation. Zoom in a bit so we can see and read together. I chose to do my presentation on the poles. So understanding primary production, the poles. The ocean is an incredibly diverse and busy place. The ocean provides a necessary resource for most of life on Earth, but it also depends on the Earth to give back nutrients to maintain its health. Humans can help provide some of these necessary nutrients for the ocean to thrive from things like runoff. These necessary nutrients can help the ocean create and sustain life through primary production. Unfortunately, humans can also harm the ocean by putting harmful chemicals in the ocean that destroy marine life, as well as other forms of pollution. Nutrients are not the only thing needed to ensure the ocean life is thriving in the ocean. Primary production also requires a consistent supply of sunlight, as most primary production is formed through photosynthesis. Cooler water, like the water near the Arctic poles, can sustain many of the necessary nutrients much better than the warmer waters that are closer to the equator. This often means that primary production is more successful in cooler and temperate climates than in tropical ones. Although this doesn't mean that tropical water is lacking in diversity in marine life. We all know the tropics are full of beautiful coral reefs and things of that nature. The waters at the poles do lack in gaining enough sufficient sunlight to promote productivity all year round, proving only productive for a few short months in early spring. In this poster, we explore data from 3 different polar arrays that have been collecting samples for a complete calendar year. Learning more about what this data means, why it's important to understand primary production, and how we can help ensure the health and future of the ocean. So first off, what is primary production? Primary production is the creation of new organic matter. This new organic matter serves as the base of the marine food web. It is also responsible for providing oxygen, as most primary production happens through photosynthesis. Primary production is needed for both marine life and terrestrial life to thrive. In our graph below, we have the data from the 3 different arrays that are located at the poles. This data shows that there is a spike in the North Atlantic in the late spring months. In the North Pacific, there are increases in early spring, while the South Pole remains mostly consistent. So here we see our graph. We have the North Atlantic here in blue, the North Pacific in this gold color, and then our South Pacific in this green color. And then to the left, we have a map of the studied arrays. The arrays that we are focusing on are the Imagery array in the top right, the Station Papa array in the top left, and the Southern Ocean array in the bottom left. So here's our Imagery array, our Station Papa array, and our Southern Ocean array. In this graph, we're studying chlorophyll, the concentration of chlorophyll. So the chlorophyll A stayed at a consistent lower levels throughout winter, summer, and fall, increasing only during the spring months. The highest point of abundance is in the spring months of May and June, approximately, with one high spike in late summer. This is when the light and nutrients are most readily available. Low points can be seen during the winter months. Primary production does vary with seasons. All the necessary nutrients and requirements like sun need to be available for primary production. In the poles, this time where everything is available is short-lived, only a few months long. The data provided relates to other oceanic processes like seasonal currents, thermocline currents, events of upwelling, and the ever-changing surface nutrients. In Array Imager C, data collected evidence of one large spike of chlorophyll A in the late spring. In Station Papa, there were less concentrated spikes in early spring. Lastly, in Array Southern Ocean, there are no extreme increases of data. All locations are low during the winter seasons. On the other hand, the Imagery array has a large concentrated spike of data, while the Station Papa has spikes of data more dispersed over time and not as high in concentration. Waters in the North Atlantic are cold, nutrient-rich, and mainly sun-deprived besides a short few months in the spring. In the Pacific, where the Station Papa is, it is further off the coast than the others. The water is less nutrient-rich in the open ocean, but the area is commonly known for upwelling. Where the Southern Ocean Array is placed, the waters are warm. This prevents primary production to thrive from the lack of nutrients available in the water. If you look at the data collected from the Imagery array, you'll notice a few estranged data plots from where the concentrated spike, one of them being the highest concentration plot recorded. So I'll just scroll back up so that we can reference that. Speaking of this one right here, and also this little guy over here that has a few below it. This could be due to upwelling. Upwelling is when the deep sea water is brought to the surface, thus bringing an abundance of nutrients with it. This is a great opportunity for primary production, but typically very short and sweet, like shown on the graph. When this happens, all the primary producers that are available at that time will eat up everything that's available, and then it'll disperse very quickly and die very quickly. Primary production and geography do have very important relationship. Warmer water towards the equator tends to have less nutrients than cooler water at the poles. The water closer to the equator is less likely to have primary production that is going to thrive. Also, coastal waters have more nutrients than open waters due to runoff and coastal shelves collecting nutrients. So, pardon me. The ocean's chemical makeup is consistently fluctuating. We're over here if we lost you. The proximity to shoreline can affect the primary production for many reasons. The first being runoff, which provides the area with extra nutrients primary producers can use to help primary production. However, too much chemical runoff can cause harmful algae blooms that actually limit primary production. Harmful algae blooms also can block sunlight from reaching lower in the water and several other harmful things to the marine life that's living in that area. Busy coastal cities also produce lots of waste and trash. When these products enter our ocean waters, they can introduce unhealthy water conditions, also limiting primary production. So, learning all of this, what questions do we have? One, how can we help? What are some ways that we can ensure primary production is thriving near our local coastlines? Does primary production mean there is less wildlife? Does less primary production mean there is less wildlife in these affected areas? If so, do these seasonal changes in primary production affect the limits on commercial fishing? This is a big question for me because I was curious if there's less primary production in an area, like say in the poles, for instance, near Nova Scotia and the Imagery Sea Ray, and there's only that primary production for a few short months. Is there going to be more wildlife in that area for that few short months? And if so, when that wildlife disperses over the winter and summer months, are the fishermen still allowed to catch the amounts of fish that they are normally allowed to catch during the spring months, or does it vary? That's my question there. Thank you all for listening to my presentation. I hope that you've enjoyed and that you've learned something.